Good morning, everyone. Today is Monday, the 5th of November. I am away at a student council function, so I will not be in school today, but I will be back tomorrow, so I can answer all of your burning questions then about proofs. Today we're going to continue our discussion on triangle proofs. So if you could take out your blue packets, we're actually going to add 2 more postulates to that. So for today, we are covering lesson 4-5. It's still called Proving Congruence. However, we're going to take a look at 2 different postulates today. We are going to look at ASA and AAS. And if you remember from Friday, the A's stand for angles and the S's stand for sides. Now, at any time throughout this recording, if I'm going too fast or you didn't get something, the substitute teacher can pause this video. So just ask, can you please pause? And I'm sure he or she would be happy to do so you guys can get all caught up. All right, so the first postulate, the ASA or angle side angle postulate. This one says if 2 angles and the included side, I'll get to that in a second, if 2 angles and the included side of one triangle are congruent to that, meaning the same thing, in another triangle, then the triangles are congruent. Okay? So let me draw you a picture, give you a visual of this. So 2 triangles that are kind of the same. Okay, we'll pretend that they are. So we are going to have 2 angles. So let's say this one is congruent to this one, and that this one is congruent to that one. Okay, so those are 2 angles. Now there's this word included side. Okay, so on Friday we looked at the SAS postulate, and I said that the included angle was the angle that fell between the 2 sides. Well, guess what? An included side is the one that falls between the 2 angles. So it would be this side for this one and this side for that one. So he literally goes in order. Angle, side, angle, angle, side, angle. Okay? The next one is the AAS postulate, or angle, angle, side. And this one states if 2 angles and the non-included side, again, we'll get to that in a second. So if 2 angles and the non-included side of one triangle are congruent to that in another triangle, then the triangles are congruent. Okay? So in the previous example, or the previous slide, we said that the included side was the one that fell between the 2 angles. Well, you can probably guess what the non-included side is. And I'll show you a picture right now. Okay, so again, just 2 random triangles. Hopefully they look congruent or somewhat congruent to you. So 2 angles. So maybe this one and this one. And then maybe this one and this one. So throughout our proof, we somehow got to that conclusion that those 2 angles are congruent. Well, if we want to include a non-included side, it's going to have to be either this one here or this one here, okay? Because included means it's between, right? So we want a non-included. So I don't know, I'll just pick this one and this one, okay? So we just created ASA AAS, AAS. Okay, so again, same, we're looking for those patterns. All right, let's look at some examples. I have two. So our first example. In this one, we are given that QS bisects angle RST and that angle R is congruent to angle T. And we want to prove that triangle QRS is congruent to triangle QTS. And here's our picture. And we have QRST. Okay? So I will continue setting this up. Remember, you can ask to pause at any moment. I realize I go through this a bit quick. All right, so as we're going through these, we need to keep in mind in the back of our brains that the two patterns we're looking for today are ASA and AAS. So those are the two patterns we're going to try and create today. All right, so we're going to kind of shy away from the ones that we looked at on Friday. All right, so as any good proof would, let's start with our given. So QS bisects angle RST and angle R is congruent to angle T. And that is our given. So we have a bit of straightforward information right here, angle R and angle T. It's always nice when we have that. So let's mark that on our picture, angle R and angle T. So we got one angle out of the way. We just got to find another angle and a side. All right, let's use this other part of our given. QS bisects angle RST. Now for this one, we're actually going to take a definition from chapter 2 dealing with angle bisectors. That would be the definition of an angle bisector. So remember that an angle bisector is going to cut an angle into two equal parts, or cut it in half, okay? So if QS bisects angle RST, well, guess what? That means this part and that part are going to be the same. Okay, so what did we just mark there? That angle RSQ is congruent to angle TSQ, and that is definition angle bisector. Okay, again, that was from chapter 2. Okay, so we got two angles. Now we just got to look for a side. Well, we're not given any other information, but I don't know if you noticed, but when I look at that, I see a side that those two triangles share. And guess what? That is QS. So QS is congruent to itself. Remember, when anything is congruent to itself, that is reflexive. So now, look what we just did. AAS, AAS. So our triangles QRS congruent to triangle QTS by AAS. All right, let's look at the next one. Last example. In this one, we are given that DL bisects BN and that angle XLN is congruent to angle XDB. And in this one, we want to prove that LN is congruent to DB. And here's our picture. This is a picture of a parallelogram, actually. We have some diagonals in there. B, D, N, L, and this is X in here. Okay, so we will set this up. Okay, now this proof is going to be a little bit different than the previous one. And the reason I say that is because if you look at the part that we want to prove, we don't actually want to prove that triangles are congruent. In this one, we actually want to prove that a part of a triangle is congruent to another part of a triangle. Okay, so this one we're actually going to be using CPCTC. So this is why I wanted to do an example like this. You can see how that's used. So let me walk you through this one. So we're going to first start by stating our given. DL bisects BN and XLN congruent to XDB. Okay. Well, again, look at that. We have some straightforward information. Let's mark it. XLN. XLN. This one. And XDB. XDB. That one. Okay? Now, let's look at the second part of our given. Or I guess the first part of our given. DL bisects BN. Okay, bisect, cuts in half. Okay, so DL bisects BN. So that means that DL cuts BN in half, or into two equal parts. Okay, so that tells us that BX is congruent to XN. And for this one, because we're talking about segments, we're not talking about angles, this one is going to be from chapter 2 again. Definition of segment bisector. Okay, there's a segment bisector. That was in your chapter 2 packet. Okay, so if we look at our picture, we don't really have any other given information to go on, but I don't know how many of you look at that, at the X in the middle, and see some vertical angles. Well, I do. So this angle and that angle are congruent. Vertical angles. So that would be what? Angle BXD congruent to angle NXL, and that is vertical angles theorem. Wow. Looks like we have two congruent triangles, one right here and one right here. AAS, AAS. It's amazing. So triangle BXD congruent to triangle NXL by AAS. Now LN and DB are congruent parts, because look at LN, LN, DB, DB. So here we go. LN congruent to DB by CPCTC. Okay? Good deal. So for today, your assignment, working on some proofs from 4-5, is going to be on pages 238 to 241. This is also written on the sideboard behind my desk, as always. So pages 238 to 241, numbers 2, 6, 9, 12, 20, 21, 22, 27, and 28. Now tomorrow we will go over both this assignment and the one from Friday. So I will be happy to go over any proofs you'd like. Bring your questions tomorrow. We're not going to move forward with anything. We are just going to review these last two sections. I know it's tough when the teacher's gone. So I hope you guys have a wonderful day, and I will see you tomorrow.